There's a career field where a single decision made in a conference room based on a computer model can unlock or destroy hundreds of millions of dollars of value, where the biggest challenges aren't always visible to the naked eye. While some are happening thousands of feet underground, others are hiding inside a process flow diagram on the surface, and the rest are buried in a contract, a capital budget, or a regulatory filing. And where the same core skills that have driven the global energy industry for a century are now being supercharged by machine learning, digital twins, and AI-powered engineering tools. We're talking about petroleum engineering and the full ecosystem it takes to actually get oil and gas from the reservoir to the pipeline. Whether you're in this field, adjacent to it, or just trying to understand how the energy industry actually works, this is your clear, honest, and modern breakdown. Let's dive right into it and see how it all works. Here is the core problem the petroleum engineering discipline is built to solve. Oil and gas don't exist in neat underground lakes that you can simply pump out. They're trapped inside microscopic pores in rock formations, sometimes thousands of feet below the surface or the ocean floor, under enormous pressure, surrounded by water, and separated from you by geology no one has ever physically seen. And even when you reach it and bring it to the surface, you're not done. What comes out of a producing well is a complex mixture of crude oil, natural gas, produced water, sand, and corrosive compounds. It has to be separated, treated, measured, and conditioned before it becomes an exportable product. The full challenge spans subsurface engineering, surface facility design, and real-time operations management. No single engineer covers all of it. Instead, a team of specialists each owns a critical piece of the chain. And supporting all of them, making it financially viable, legally sound, and operationally organized, is a wider team. That's exactly what we're going to cover today. Now let's explore the 4 essential engineering pillars of the oil and gas industry: reservoir, drilling, production, and facilities engineering, and see how they work together. Reservoir engineers are the strategists. They build digital twins of underground formations to predict how much oil is recoverable and plan the best way to get it out. AI now compresses reservoir modeling from weeks to hours, using machine learning to calibrate data and predict field performance with incredible accuracy. Drilling engineers are the architects. They design precise well paths that can curve horizontally for miles to hit specific rock layers deep underground. Today, AI algorithms monitor real-time data to optimize drilling speed and identify potential hazards before they happen, making operations safer and more efficient. Once the well is ready, production engineers take over. They manage the well's entire life cycle, using artificial lift systems to keep the oil flowing for decades. AI-powered platforms now monitor hundreds of wells at once, flagging anomalies and recommending changes to maximize output and reduce downtime automatically. Finally, facilities engineers design the surface infrastructure to separate and treat the oil and gas so it's ready for the pipeline. AI-driven digital twins and predictive maintenance now prevent equipment failures weeks in advance, saving millions in lost production every day. Together, these 4 disciplines and the power of AI are driving the future of energy production. Technical career videos often skip this. Engineering disciplines don't operate in isolation. They're embedded in a larger organizational ecosystem that makes projects financially viable and operationally executable. Finance teams translate engineering into investment decisions, building models to determine if a project gets approved. Legal and contracts teams structure the agreements, from joint ventures to service contracts, that govern every jurisdiction. Government relations secure the licenses, while HSE teams set the standards for safety and environmental compliance. This ecosystem, supported by HR and IT, is what allows a complex energy project to truly work. Understanding your place in this network is how you contribute at the highest level. Engineering is the core, but the ecosystem is the key to project success. Let's correct a persistent misconception. The hard hat on a rig image describes a minority of professionals in these disciplines. Most petroleum and facilities engineers work in offices in energy hubs in North America, Asia, Europe, Africa, etc., running software and technical models. They review technical documents, build economic models, and present recommendations for 9-figure capital budgets. Some engineers rotate through field assignments onshore and offshore. Offshore platforms typically operate on 28-day rotations, but even there, the work is about managing data systems and making operational decisions. This is a truly international career. Skills are in demand wherever hydrocarbons or new energy infrastructure are being built. Engineers with strong technical credentials and a tolerance for international mobility can build careers that span multiple continents and project types over a 30-year arc. The question every professional is asking is, are these careers future-proof given the energy transition? The transition is real and accelerating, but fossil fuel demand remains significant through the 2030s, especially in hard-to-electrify sectors and in economies where energy access is still the primary driver. The real durability lies in skill transferability. Your technical competencies map directly onto new energy technologies. Reservoir and drilling skills apply directly to geothermal energy using the same subsurface characterization principles. Carbon capture is fundamentally reservoir and facilities engineering applied to a new, sustainable purpose. Hydrogen storage requires the same pressure management and integrity assurance developed in the oil and gas industry. Position yourself by layering data science and AI fluency over your deep technical foundation. This combination is exactly what the modern energy industry is competing to hire. The future is yours to build. Whether you work in petroleum engineering, another technical discipline, or a completely different field, here are insights worth taking seriously. The first is the value of systems thinking at the interfaces. The most expensive mistakes in oil and gas don't happen within individual disciplines, but at the handoffs between them. For example, reservoir assumptions that didn't account for facility constraints or facilities designed for a production profile that the reservoir couldn't sustain. The professionals who add disproportionate value are the ones who understand their own discipline deeply and understand enough of the adjacent disciplines to manage the interfaces intelligently. This principle applies universally. The second is that AI is reorganizing expertise, not eliminating it. In each of the disciplines discussed, AI is compressing the time required for analysis, developing patterns that humans miss, and handling the routine cognitive work that used to consume engineering hours. But the judgment calls that determine whether a project succeeds, interpreting model outputs in the context of real-world constraints, assessing risk under uncertainty, and making the call when the data is ambiguous, those still require experienced engineers. The premium is shifting toward professionals who know how to work with AI tools, not compete against them. The third is that technical careers built on first principles travel further than careers built on specific tools or configurations. The petroleum engineers whose skills transferred most seamlessly to geothermal, CCS, and hydrogen were the ones who understood the underlying physics, fluid flow, thermodynamics, and pressure management well enough that the specific application was a relatively small adaptation. That depth of understanding is what makes a career resilient across technological shifts. Petroleum engineering and the full ecosystem that surrounds it are one of the most technically demanding, globally distributed, and consequential fields in the professional world. And it's navigating a genuine transformation, not just in its tools, but in what the industry itself is being asked to become. The professionals who will define the next generation of energy aren't the ones waiting to see how the transition unfolds. They're the ones who understand their discipline at the level of first principles, treat AI as a genuine force multiplier, and keep their skills pointed toward where the hardest problems are heading, not just where they've been. That's the pattern worth following, in this field and in any field. If this gave you a sharper picture of how this industry actually operates, including the roles that usually get left out of the conversation, give it a like. It genuinely helps this channel reach more professionals who find this kind of breakdown useful. And if you want more clear-eyed analysis of complex industries, career dynamics, and how AI is reshaping professional work, subscribe. No hype, just signal. See you in the next video.